Quantum computers have the potential to solve problems that could be world-changing, such as the design of new medicines or new ways to solve the world's energy problems. But to do this, they're likely to need millions of quantum bits, or qubits, all operating in sync. Now, our team has designed a quantum computer chip that can realise that goal, using readily available silicon chip technology. Modern-day computer chips already contain billions of identical transistors crammed onto a square centimetre of silicon, each one less than 20 nanometres in size, which is 1,000 times smaller than the width of a human hair. However, remarkable as they are, today's computer chips cannot yet harness the quantum effects needed to unlock the power of a quantum computer. In 2015, our UNSW team showed how to convert the silicon transistors found on computer chips into qubits, and demonstrated the first quantum logic calculation between two silicon qubits. Now, our team, including Dr. Menno Veldhorst, who is now at QTech in the Netherlands, have designed a blueprint for a quantum computer chip that can be fabricated using the same manufacturing plants used to make today's silicon chips, and which can incorporate the millions of qubits needed to realise the promise of quantum computing.
Our design incorporates conventional silicon transistor switches to turn on operations between qubits in a vast two-dimensional array, using a grid-based word and bit select protocol, similar to that used to select bits in a conventional computer memory chip. By selecting electrodes above a qubit, we can control its spin, which stores the quantum binary code of 0 or 1. And by selecting electrodes between the qubits, we can perform 2-qubit logic, or calculations between qubits. The reason that quantum computers will need millions of qubits to solve really important problems is because all practical qubits are fragile, and even small errors can build up and lead to wrong answers. So we need to use error-correcting codes, which employ multiple qubits to store a single piece of data. Our chip blueprint incorporates a new type of error-correcting code designed specifically for spin qubits and involves a sophisticated protocol of operations across the millions of qubits. Our design is the first attempt to integrate on one chip all of the conventional silicon circuits needed to control and read the millions of qubits needed for quantum computing.
It took about 20 years to go from the first transistor to a chip with 1,000 transistors, and then another 20 years to reach 1,000,000 transistors on a chip. By using current chip manufacturing technology, our progress will be a lot faster, although there's still a lot of engineering work needed to take this chip design and turn it into reality. But given the potential benefits to mankind that quantum computing could realise, we believe it will definitely be worth the investment.